Hi all, in this session we are going to learn about error handling mechanisms followed in data link layer of a network model. The various error handling mechanisms include error control and error detection. The main functions of a data link layer are framing, flow control and error handling. In this session we will learn about how error is detected and how it is corrected. First, let's understand what is an error in data transmission. The data transmission between devices may not be always accurate. Error is a condition when the output information does not match with the input information. That is, the message received by the receiver may be different from the send message. Consider the example. The sender message is 1001101 and the received message is 100111101. So here the 0 is changed to 1 in the receiver side. So this is a error because the message received at the receiver side is different from the send message. There are many reasons for error. If the power supply in the system is not at the specified voltage, the component may not operate properly. Error may occur if the system may be operating at its low or high temperature limit. Error may occur due to crosstalk from adjacent signals, which may lead to the corruption of signal. Data signal in the transmission wire may get weak due to resistance, inductance or capacitance. So these all are the various sources of errors. There may be many other reasons like a thunderbolt or a voltage fluctuation, etc. Next, let's learn what are the different types of errors. Generally, there are two types of errors, single bit error and burst error. In single bit error, one bit of a given data may be changed from either 0 to 1 or 1 to 0. That is, a single bit in the entire data is corrupted or modified while receiving at the receiver side. A single bit error is an isolated error condition that alters one bit but does not affect the nearby bits. Single bit errors are not a common type of error in serial communication. Let's understand single bit error. Here, this is the sender message, this is the receiver message. In this bit, the data is changed from 0 to 1 at the receiver side. So a single bit is changed. This is called as single bit error. In case of burst error, there will be two or more bits got corrupted from 1 to 0 or 0 to 1. See the example. Here the message is 10001101 and at the receiver side it is received as 00011100. So 3 bits are corrupted here. So if the number of bits changed are more than 2 or 2 or more bits are changed, then it is called as a burst error. Burst errors are high at higher data rates. So if we are transmitting data at a higher data rate, that is higher speed, then the burst errors are high. Next, let's learn the various error handling mechanisms. Error detection and error correction are the two error handling mechanisms. First, let's see what is error detection. Whenever a message is transmitted, it may get either scrambled by noise or the data may get corrupted. In order to avoid this, we use error detecting codes, which is an additional data added to the given digital message. This data or this additional data will help us to detect if an error occurred during the transmission of the message. A simple example of error detecting code is parity check. We will learn about these mechanisms in detail in the coming slides. In error detection, it will identify only whether an error is occurred or not. There is no error correction mechanism in case of error detection. So retransmission of the data is the only option to get the correct data. In error correction, along with finding out an error is occurred, it will also identify in which bit locations that particular error is occurred. So we can easily identify that bit location and we can correct the code. So in case of error correction, it will find out both detecting the errors and detecting the location or the bit location of the data where the error is occurred, and it will correct that bit locations accordingly. So in simple words, error detection will detect only whether there is an error or not, whereas in error correction it will identify the presence of errors and also it will detect the exact location of the corrupt bit. The various error detection techniques include redundancy, parity checking. This parity checking can be done in many ways like vertical parity checking, horizontal parity checking, etc. Checksum, cyclic redundancy check or CRC. The error detection techniques include Hamming code. First, let's learn the eradication mechanisms like redundancy and parity checking in this session. In redundancy check, the eradication is performed by sending each data unit twice. That is, from the sender side to the receiver side, the data units are sent twice. The same data unit is sent twice. And these two units are compared at the receiver side. And if these two units are exactly same, then it will accept that data. Otherwise, it will require for retransmission. It is like while we are setting password in Google account or WhatsApp account. While setting our password, we have to type our password twice, so that it will compare whether both these passwords are correct. If both these entries are same, it will store it in the database. Otherwise, it will ask us to re-enter the password. That same concept is used here. The data is sent twice, and if both the units are same during the comparison, it will accept that data. Otherwise, it will ask for retransmission. Redundancy can be character redundancy or message redundancy. When the data unit is a single character, it is called as character redundancy. If it is the entire message, then it is called as message redundancy. The disadvantage of this mechanism is every time we have to send the data packet twice. For example, if there is 1 million bits of data, we have to retransmit the 1 million bits of data so that these data units are compared to find out whether it is same or not. So this is not a feasible mechanism in real-time communication. So the next method is parity checking. In parity checking, we are adding some additional bits called parity bits. These parity bits are used for detection and correction of the errors. The data bits along with the parity bit form a code word. So consider this example. This is a 8-bit data unit. The first 7 bits from the LSB are data bits, and the MSB bit or the 8th bit from LSB is used as parity bit. So this is an additional bit, and this additional bit or this parity bit is used for checking whether the data is received correctly in the receiver side. There are different types of parity checking: even parity checking and odd parity checking. If number of ones in the data is odd, then 1 is added as parity bit. If the number of ones is even, then 0 is added as the parity bit. So this scheme makes the total number of ones even. That is why it is called as even parity checking. I will explain this with an example. The 7 bits are data, and this 8th bit or the MSB bit is called as parity bit. So first we will check how many bits are 1 in this data. So in this 7 bits there is only 1, 2, 3. So 3 ones are there. 3 is an odd number. So if the number of ones in the data is an odd number, then we will add 1 as the parity bit. So I added 1 as the parity bit. In the second example, 0, 1, 0, 1, 1, 0, 1. In this data we will check for number of ones 1, 2, 3, 4. So if it contains even number of ones, 4 is even number of ones. If it contains even number of ones, we will add the parity as 0. So if we consider the entire data unit, that is the data plus the parity bit, then the number of ones is even. That is why it is called as even parity checking. See in this example, 1, 2, 3, 4. The number of ones in data is 4. 4 is a even number. See in this data unit, the data 7-bit data plus 1-bit parity bit. So totally there will be 1, 2, 3, 4. So this here also 4 is an even number. So whatever the case it is, in an even parity checking, the number of ones in the entire data unit is 1. So based on this concept, we can identify whether an error is occurred in the data or not. Let's understand this concept with an example. Here the sender is sending a data 1, 0, 0, 0, 1, 1. So first let's compute how many ones are there in this data. 1, 2, 3. So if there is odd number of ones, 3 is an odd number. If there is odd number of ones, we have to add 1 as the parity data. So I have added 1 as the parity data, and this entire data unit is transmitted to the media. In the receiver side, this data is received and it will compute the parity bit. In the entire data unit there is 4 ones, so that is even parity. So if it is even parity, it will accept the data. That means if I change this 1 to 0, then there will be 1, 2, 3. Only 3 ones are there. So if we check the parity bit, the number will be odd because 3 is an odd number, so it will reject the data. So thus we can identify whether the data is changed or not. In the receiver side, it will check for the even parity, if the number of bits in the entire data unit is even or not. If it is even, then it will accept the data. If the number is odd, it will reject the data. This is how eradication is performed in computer networks. The other mechanisms like cyclic redundancy check and checksum will be discussed in our next session. Thank you.